Alright, this video is for the lesson 2.2 homework for college algebra. Still looking at functions and their graphs. So, number one, what do we got?
The function f is an even function if f times negative x equals blank.
Okay, wait. If
Yes.
f of negative x equals blank,
Such a function is symmetric with respect to the blank. And the options.
okay, you're wanting to know if it's an even function?
Yes.
Okay.
First options are negative f of x and f of x. And the second blank options are origin and y-axis.
Okay, what are the two options here?
Negative f with parentheses x or f of x.
Like that?
Yeah.
Okay. This is one. So a function f of x is even if f of negative x equals f of x. And it is odd if f of negative x equals negative f of x. So negative f of x would have to equal, right? F of negative x equals negative f of x?
It's asking if it's an even function.
That's an
so it would be
oh, no.
f of x.
If f of negative x equals f of x. Sorry, yes.
The graph is such that the function is symmetric with respect to the y-axis. Yeah, it's the y-axis.
Okay. So symmetric to y-axis.
Yes.
And the next one's talking about if f is an odd function.
Okay, so what's the if
F of x. You said it earlier, negative f of x.
if how is it phrased on here? If f of negative x equals negative f of x. And I'm guessing that one's symmetric to the x-axis.
It doesn't ask.
Oh, doesn't?
It does. Oh, okay. It's origin.
Oh, symmetric to the origin, that's right.
Oh, you only got one chance for that.
Sorry.
I'll let you do it again. A function determined by two or more equations over a specified domain is called blank function.
What are your options?
Click the wrong thing.
Piecewise?
Even, odd, and a piecewise. Oh my goodness.
What the heck is a piecewise?
So a piecewise function, again, show you an example. Here's what a piecewise function. So a piecewise function looks something like, it can look like this. Pull up.
Is that the answer, piecewise?
I'm not sure. I'll have to look at the definition. So I don't know if you can see that.
Like the whole thing, or like just the curve, or what?
Well, so see, this is a piecewise function. It's a combination of these three functions or these three relationships for a specific domain. So how is that one? How is
Basically, just what you said. A function defined by two or more equations over a specified domain is called blank function.
is a function that's defined on a sequence of intervals.
Okay.
That's what it says piecewise is. To show you even and odd functions. Hopefully they've got pictures. Okay, so here's an even function. So it's symmetric across the y. I could fold this on the y and everything matches up. Okay? Odd function, like a sine wave, folded, well, you don't really fold it across the x, but you rotate it across the origin. Rotate it 180 degrees. So that's what it says, rotational symmetry through 180 degrees. So if you took this piece that's right here and you rotated it 180 degrees, it would line up with this second piece. That's an even and an odd function. There's more things to it than just
Rotating.
that, like how you tell if it's even and odd. So, like, here's an example. X squared plus x to the fourth plus 8x to the sixth is even. X plus x cubed plus x to the fifth is odd. But again, it's swapping out those pieces. So, like for an even function, if you plug in a negative x into the function, you substitute that out, you get the same function. If you plug in a negative x and everything changes signs, I don't know if that makes sense, then it's an odd function. If neither of those work, then it can be neither. That's an option as well. So this one was piecewise?
Yes, it was.
Okay. All right, number 4.
Select the correct choice below if necessary from the box. It says the function is increasing on the intervals when.
Okay, increasing? Is that what it's asking, where it's increasing?
It says use the graph to determine open intervals on which the function is increasing, if any. Open intervals on which the function is decreasing, if any.
Oh, does everybody have a quadratic?
Yeah.
Does everybody's quadratic open up like this?
Yes.
Okay, so hang on, I'll do both. But some of you guys are going this way? Okay, so increasing is where the y's are getting bigger, where the y values increase. You always move from left to right, so like in this direction. So from your vertex to infinity, so whatever the x value is here, whatever the x value of your vertex is, that's the interval of increase from that point to infinity. If it's flipped like this, your increase is from negative infinity, -8, good gravy, y'all. Negative infinity to whatever the x value of your vertex is. This is the increasing piece. Here's where your y's are getting bigger, from negative infinity to whatever the x value of your vertex is.
So should it be bracket, whatever you're at?
The x should be a bracket. The infinity should be a parenthesis. So it is. It should be parentheses on both. So like Shelby's, this was a -2. That was the x value. That -2 is the crossover point. It's the point where the function begins to increase. And it's also the point where the decrease, because this would be the decrease here. I know it's going up. I know the function is going up. But you have to follow a path, left to right. And it's how your finger moves. And so from left to right, your finger moves down. But that vertex is the crossover point where it changes from decreasing to increasing. That's why it's a parenthesis.
I put mine in all parentheses. I think I wrote it.
Function is increasing from negative infinity to -2. Look at your x value. Right? So it's not the y value, it's the x value.
I guess it doesn't, it doesn't include the vertex because the vertex is no longer going up or down.
Again, it's the crossover point. Yeah, it's kind of the even keel of the entire function. So it's the value, so again, when we're increasing, it's the value that's just a scotch bigger than -2. Or if you're going this way, you get as close as you can to that x value without actually touching that x value, without including it in the set.
It's, I said I got it wrong.
Okay, let me look. So if it's opening up this way, your decrease is going to be from negative infinity. Oh my gosh, why do I keep writing an 8? Negative infinity to that x value. If it opens up, your decrease here is going to be from that x value to positive infinity. So again, even though it's going down, the x's are getting bigger. It's the x values, not the y values. All right, what's our next one look like?
The constant.
Yeah, there's no interval where it's constant. Or on 4. I was still on 4. Yeah.
Go to the part 3.
Oh, what's it say?
What's the constant at the end?
What's the constant? That's looking like if it starts going flat. So again, piecewise functions, when you have all these pieces put together like this, that would be a constant interval. The flat.
The same type of question, just different graph.
What kind of, are they quads or are they something different?
Something different.
It's like a line, like a diagonal line, and then it starts going like this. So it's like this.
Yeah.
It's
Like a clock.
I think it's. might be-
So this direction like this,
Yep, and then straight.
and then straight like this.
Yeah, that's what mine looks like.
What do these endpoints look like?
Arrows.
An arrow.
Arrow, and then an arrow here.
Yep.
All right, do we have any other looking graphs?
Mine's flat and then goes down.
So flat and then goes down like this,
Yes.
and they're arrows.
Yes, ma'am.
Okay, so increase. So from left to right, there's no increase. We decrease and then we're constant. So is that a choice for increase?
There's no interval on which the function is.
I believe that's
Yeah,
correct.
it is.
Okay, so decreasing for this one, here's where we're decreasing. So we're going from negative infinity to whatever that x value is. And then your constant interval is from that x value to positive infinity. So this one as well does not have an interval of increase. Because again, constant, decreasing. So then decreasing is going to be that x value to infinity. Your constant is going to be from negative infinity to that x value. Okay, because this keeps going on and on forever, so we just have to imagine that we're in infinity here, or negative infinity. So yeah, watch the signs. Again, your brain likes to do that because you're like, oh, it's going down towards, and your brain wants to tell you the y value. It's always the x. Okay. 6.
Looks like a W. Mine looks like a W.
So something like,
So it's
Like
it's
this?
all in the first quadrant.
is that what it looks like?
Yeah.
Anybody have an upside down one of those? And its area of increase and all that, interval of increase?
Mine.
The function f has a relative maxima or maximum at blank and a relative maxima or maxima are blank.
Okay, so relative maxima, and then what else is it asking for?
And the relative maxima are blank.
Okay, so here's another one where you need context. Okay. Okay, relative maximum is a point on a graph where the y-coordinate is higher than all other nearby y-coordinates. It's also the point where a function changes direction from increasing to decreasing, making it a peak on a graph. So that's the key part, changes direction from increasing to decreasing. So here, let's get this picture, see if this picture will come up. That's a good one. Whoop. So you can see in this graph, here's the relative maxima, and then here's the relative minima. So this thing, like our graph that we have, if I can find my thing, it's increasing this way, but it's that turnover point. It's that crossover point. So like this would be the relative maxima. I believe what it's wanting is the x value for this one. And then I think for the second one, it's wanting, I think, the y value. So whatever your x value is,
Yeah.
and then this one should be the y value. How's that second one phrased?
Like the second part of that.
That question, yeah.
The relative maxima is.
Okay, so like the first question is it occurs at, and then the second question is, so yeah, occurs at the x, but the value of that maxima is the y value.
Then it's asking for the minimum.
Okay, so your minima are here.
Says use a comma to separate answers as needed.
Yeah. So you've got two. So again, your minima is where it goes from decreasing to increasing. So maxima is from increasing to decreasing. Minimum is from decreasing to increasing. So we're decreasing, and that switchover point, that's your minima.
The next one's asked for maxima and minima. It's just given a different thing.
Different looking graph.
Yes.
So
Weird info.
I don't see points, so that's
something like this. Okay, let me see what it says. The graph and equation of the function f are given. Use the graph to find any values at which f has a relative maximum, and use the equation. So here's the equation. 2x cubed minus 6x squared minus 18x plus 9. So use the graph to find a relative maximum. Use the equation to calculate the maximum. Use the graph to find any values which it has a relative minimum, and use the equation to calculate the relative minimum for each value. Okay. If we have different equations, I'll work those. It's, all right. Let's look at this on a graph. Again, why I like Desmos. So we've got, this one is 2x cubed minus 6x squared minus 18x plus 9. Okay. So we know this is our maximum, right? Why I like Desmos. It marks the point. So our max on this one, the x is -1 and the y is 19. There is a way to do this. All right, so on the calculators that we have, so again, I showed you Desmos, but I just want to show you on here how it works. So if I do 2x cubed minus 6x squared minus 18x plus 9, and zoom out, menu 6 has all these options. Minimum, maximum. So let's do the maximum first. You get this, oh, it would help if you could see what I'm doing. So let me start over. Graph the function. You can zoom out. Menu 4 is your zoom menu on these. Out is 4. And then menu 6, you can find the zeros where it crosses the x-axis, the minimums, the maximums, intersections. But if we want to do maximum, we get this dashed line, and what we have to do is capture that peak, and it'll do the same thing as Desmos. It will plot that point on there for us. So same thing, we could do the minimum. So menu 6 and minimum is 2. Capture it. It gives me the x and the y value of it. So does anybody have a different equation on that one?
I have 2x cubed plus 3x squared
2x cubed plus 3x squared
minus 12x plus 1.
minus 12x plus 1. So Desmos, I like Desmos better because there's less steps. I can just type it in, 2x cubed plus 3x squared minus 12x plus 1, and I can literally click on the maximum. So the max for this one, the x is -2, the y is 21, and then the minimum, the x is 1, the y is -6. So I like Desmos just because it's less, there's less of a process to get to what you're looking for. All right, number 8.
Determine whether the function is even, odd, or neither. Then determine whether the function's graph is symmetric with respect to the y-axis, the ordinate, or neither.
Okay, so give me your function, Peyton.
F of x equals x power 5 minus 4x.
Okay, so if it's even,
This one.
I should be able to do f of -x. So I change x to the 5th to -x to the 5th minus 4, and then x would be a -x. So -x to the 5th is going to give me a negative value. Odd exponents, you can get a negative value. This one here, though, -4 times -x is plus 4x. So it's not even, because otherwise this would equal this. So to check if it's odd, then we do negative f of x. And what we do in that one is we put a big negative sign out in front of the original function. And we distribute that. So negative times x to the 5th is -x to the 5th. Remember, it's a -1 we're distributing. -1 times -4 is a positive 4x. If these two match, then it's odd. So you always check if it's even first, because that gets you one step of the process. If they don't match, then you go to the second step. If they match, it's odd. If they don't match, then it's neither. So symmetric should be to the origin. Again, Desmos, x to the 5th minus 4x, kind of get a visual. Think about it turning this whole function once, twice. And so it's symmetric to the origin. Does anybody have a different one there? X cubed minus 2x. So f of -x would be -x cubed minus 2 times -x, which would be -x cubed plus 2x. Doesn't match, so it's not even. And then negative f of x would be the negative sign out in front of the whole thing, which gives me -x cubed plus 2x. We've got a match, so it's odd, and it would be symmetric to the origin. Okay, anything else? All right, so 9. 9.
No, 10 is a 12-part question.
Okay, so let's get through 9 and then we'll look at 10.
2x squared plus x to the 8th
Wait, 2x
squared
squared plus
to the 8th power.
x to the 8th. Okay. So f of -x would be 2 times -x squared plus -x to the 8th. Because the exponent is even, the answer is going to be even. So same with this one. So if these two match, we have an even function. And it's symmetric to the y-axis. Any other different ones on that? No, we're all freaking out over number 10.
Yeah,
Yes.
12 parts.
All right, let's take it a piece at a time. What's
Says the domain of f, and f is
Mine goes like it's this
yeah, it's like a straight
straight,
line.
and then the
okay? So first question is domain, is what you're telling me.
Yes.
Are the ends arrows?
Yes.
Yes.
If both ends are arrows, it does not matter the shape of the graph. It's negative infinity to positive infinity. So it could look like this. It could look like this. It could look like this. It could look, domain is negative infinity to positive infinity.
Range.
Okay, range. Find your smallest y value on your graph. So here's your coordinate plane. Again, no matter what the shape is, whatever your smallest y is. Now, depends on how it ends. If both ends are going up like this, it's your smallest y to positive infinity. If both ends are going down, pointing down like this, it's your biggest y. It's from negative infinity to your biggest y. If you've got two different ends, one something like this, and if you want me to look at it, I will. One end is going up, one end is going down, then it's negative infinity to positive infinity.
And if it's just to make sure it's got a
Yeah,
line.
so
then
yours is from this point to positive infinity.
that would be -1 to positive.
Yeah, so do most of you guys, do they look, here's one that I saw like this.
Yeah, that's what mine looks like.
Anything different? What was yours different? Same. So this one would be from this x value, or from this y value, and it would be a bracket to positive infinity. Okay, domain, range, what else?
X-intercept.
Okay, x-intercept. Wherever, let me kind of see what it looks like again. Yeah, it looks like there should be two. Because it looks like the x-axis comes across it like this.
Careful, because it does ask it a little bit different. The left x-intercept, the function is
Does it want just the x value?
Yes.
yes.
Okay. So whatever these two x values are here, those are your x-intercepts. And it wants the left one first.
Gives you the left.
Oh, it gives you the left one.
And then the y-intercept.
So same thing, wherever it crosses the y-axis,
Mine was where it changed from constant to.
it looks like everybody's is. So the y-intercept is going to be the y value of wherever it crosses the y-axis.
Over what interval is f increasing?
Okay, so from left to right, constant, decreasing, increasing. So whatever this x value is, so it's increasing from that x value to infinity. Does it ask decreasing too?
Yes.
So whatever this x value is,
Mine says it was wrong.
ooh, let me see.
Put brackets.
Are we
Did you
supposed
put
to
parentheses?
Yeah, I put parentheses.
You're supposed to put a bracket?
Yeah, are we
No.
supposed to put parentheses?
Because
It's the x value, sugar, not the y value. X values, not y values. So your decreasing one on this is from this x value, which should be 0, to this x value. Whatever you had for your increasing. And then does it want constant as well?
Wait, which x value?
Yes.
The x value?
So from this x value to this x value would be your decreasing.
Okay.
So the constant here is from negative infinity, and again, I should have like done these like x1 and x2. x1, x2, x1, x2.
Over what interval is f constant?
So negative infinity to this x value.
To the minimum? Is that what you said?
No, to this x value. Okay, what else in this one?
What is the number at which f has a relative minimum?
Minima would be this x value, so this is the minima.
What is the relative minimum?
Would be the y value of that. So where it is the x value. What it is the y value. Does it ask for maxima?
No, it says what is f of negative 4 is what mine is.
F of negative 4. Go to wherever x is negative 4 and whatever the y value is.
Then question 11 has 11 on 10 parts.
Is that all for this one?
No.
Okay.
What is the rightmost x value where f of x equals 3?
Oh. F of x equals 3. Go to, is it this point? Is this where y is 3? You're looking for where y is 3. If it's phrased like that. Let me see.
Why is the right right there?
And it says what is the this one right here. Well, what is the rightmost? Oh, 'cause that would be this one. So 5. Yeah, 'cause that's the rightmost value. So it's, you go to where y equals 3, and it's going to hit like in 2 spots. Like this is going to be y equals 3. So the rightmost is this x value. And if it asks for the leftmost, it's that one's x value.
Is f even, odd, or neither?
I would say neither.
Yeah.
Because it's not symmetric around the origin or the y. All right, so let's do this. If you want to work with, there's 2 more questions on this one, 3 more questions on this one, 5. We'll pick it up tomorrow. This is why I wanted to start early on this stuff.